All right, this is the second video for our for the take-home quiz 3.5, and this will cover scenario 2 and 3, or page 2 of that. So, the College Students Journal investigated differences in traditional and non-traditional students, where non-traditional students are generally defined as those who are 25 years old or older. Based on the study results, we can assume that the population mean and standard deviation for the GPA of all non-traditional students is mean of 3.55 and a standard deviation of 0.45. Suppose that a random sample of 100 non-traditional students is selected from the population. So N happens to be 100. From the population of all non-traditional students that is normally distributed. Give the mean of the sampling distribution of X bar. Well, that's easy. The mean never changes, so the mean just happens to be 3.55. All right, and so what would you put in this is what you would need to put into the Google form, 3.55. Give the standard deviation of the sampling distribution of X bar. The standard deviation of the sampling distribution is a little bit tricky and has this formula. Standard deviation of the population divided by the square root of n, which in our case would mean 0.45 divided by the square root of 100. And so when I go to the calculator and I take 0.45 divided by the square root of 100, I just do 100 raised to the half power. I end up getting 0.045. Okay, because essentially this is 0.45, the square root of 100 is 10, but I just get 0.045, and this is what needs to go into the into the Google form. It only has 3 decimal places, this one only had 2, so that's the way it'll go in. What is the approximate probability that the non-traditional student has a mean GPA of between 3.4 and 3.65? First off, they did not give me a percent, all right? They asked for a percent. So since they asked for a percent, I'm probably going to look at a norm CDF, all right? And we happen to know from up above that our mean is 3.55 and our standard deviation is 0.45, and the non-traditional, that means we are only dealing with one student. All right, now, anytime they give you a range like this, a range of values, it's going to be easier to work with a norm CDF because you have a lower bound and you have an upper. So if they give you a lower and an upper, you probably want to work with a norm CDF. Drawing a picture, it's going to look something like this. 3.55 is right here, because that's our mean. And then we have 3.45, and then we have 3.65. And we want to know that probability. We're looking for the area in between. So if I go norm CDF, lower bound, because they gave me a range, 3.45, upper bound, 3.65, mean of 3.55, standard deviation of 0.45, and I didn't have to use the 0.045 because I'm only working with one. All right, so second vars, normal CDF, lower bound 3.45, upper bound 3.65, because that was the upper part of my shading. Mean was 3.55, and my standard deviation was 0.45 for the single student. And we end up getting a probability equal to 0.1758. Box that. That's what you're going to put into the Google form. Number 13, what's the approximate probability that the sample of 100 traditional students has a mean that exceeds 3.62? So they're asking for a probability. So we have a choice here. We can either do norm CDF or we can do a stats test norm. It'll be easier to use a stat test norm, all right, because they gave a sample of size 100. I'm going to go ahead and write mean equals 3.55 because that was the mean for this, all right. The standard deviation of the population happened to be 0.45. And we're looking for the probability that x bar is greater than 3.62. So let's draw a picture of this. We have a 3.55, and right here we have 3.62, and we want the probability that 100 students is greater than that. So I'm going to do this, since it's a sample of size 100, I'm going to go stats test z-test. And when I go there, here's what all it asks for. Stats, test, z-test, press enter. It asks for the mean. Well, the mean in this case, we need to write this down, the mean in this case was 3.55. The standard deviation in this case was 0.45. We want to know if x bar is going to be greater than that 3.62. And we had a sample of size 100. So x bar equals 3.62. N is 100. And we shaded to the right. So we need to have a shade greater. We need to have a shade greater. So I need to make sure I switch that to that it's a greater than sign. And we're just going to go ahead and have that calculate that. And when I do that, I get the probability that z is greater than 1.555 equals 0.0599. What I just boxed is what needs to go into Google Form. All right. And if I go stat test and I actually went ahead and drew this thing instead of calculate, so I'm going to arrow over and draw it. We see that we shaded up to the right. We have a probability of 0.0599. Okay, and so that matches kind of what we have. All right, scenario 3. A survey is planned to determine the mean monthly family lodging costs of employees of a large company. The population's lodging cost is $2,350 with a standard deviation of $273. Given a simple random sample of 150, so we have n is 150. What is the likelihood that costs are less than $2,300? So real quickly, the fact that I'm working with a sample size greater than 1, I probably want to use a stats test z-test. That's probably the way I'm going to want to go. So what was my mean? Well, they tell me my mean is 2,350. My standard deviation in this case is $273. My x bar, the part that we're interested in, is $2,300. And my sample size is, in this case, 150. And they say are less. So my shade should be a less than. So my shade should be a less than. And if I was drawing a picture of this, which I really need to do to make sure I get this all figured out into the calculator and make sure it makes sense, the population lodging cost is $2,350. Great. We're interested in 2,300. So this goes to, it looks like, negative infinity. So this is what we're looking for. And we're going to go stats, test, z-test, and test all this out. Stats, test, and this is not the only way to do it, but this is the way I'm going to approach it. So my mean, 2,350. My standard deviation, 2,730. My x-bar, 2,300. My sample size of 150. And remember, we're shading to the left because we wanted a less than. When I calculate that, I end up getting the probability that z is less than negative 0.2243, and that equals 0.4112. So this right there is my answer. I'm going to rerun that real quickly to make sure I didn't make a mistake. So stat test, z-test, 2,350, 27. Oh, I do have an error. My standard deviation is not 20, it's 273, excuse me. That makes a big difference. So what it needs to equal is 0.0124. All right, 0.0124. Probability that z is less than negative 2.243. Run this one last time, make sure I have it right this time. Mean of 2,350, standard deviation of 273. 2,300, yes, this looks good. All right, so 0.01244. Now, could you have done that as a norm CDF? And the answer is yes, you could have. So let's try that out for those of you who prefer to do it as a norm CDF. So second vars, norm CDF. My lower, we went to negative infinity. My upper, we stopped shading at 2,300. My mean was 2,350. Now be careful with your standard deviation, all right? Because you have to account for that sample size. So it's 273 divided by 150 caret, this is the caret button right here, 0.5. And if we do that, we should get exactly the same answer, and we do, 0.01244. All right, regardless, you can do the stats test, or you can do the norm CDF, negative infinity, 2,300, mean of 2,350, standard deviation of 273. 273 divided by the square root of 150. From a sample of 375, how many? So that anytime I do how many, I'm looking at an expected value, but I'm going to need to run a norm CDF. Families are expected to have lodging costs between 2,323 and 2,364. They give me a range, they give me an interval, they give me a lower and an upper. And usually when they give me a lower and upper, I probably need to start with a norm CDF. So I'm going to go ahead and write that down because I probably need to be starting with that. I need to go ahead and draw my picture to make sure I have this all correct. My mean happens to be 2,350. That hasn't changed. 2,323 is below that. 2,323, that's my lower bound. My upper bound is 2,364. We're looking for this area. All right, so norm CDF, lower bound 2,323, upper bound 2,364, mean 2,350, and standard deviation of the population is, in this case, 273, if I did it right, and I did this time. So second vars, norm CDF, lower bound 2,323, upper bound 2,364, mean 2,350, standard deviation is 273. Because we're talking about what's the probability of a single family, because that's what we're going to do first is a single family. When we do a single family, we find out that the probability that a single family is 0.0598. But they didn't ask for the probability. They asked for how many. Because they asked for how many, that's the expected value of n times p. So in this case, sample of 375 times 0.0598 equals 22.44. And for what I want you to put in the Google form, I want you to put in 22.4405. Don't round, right? Take everything to 4 decimal places. Anything that you can take to 4 decimal places, please do. All right, that's our second video, and that covers scenario 2 and 3. The next video covers scenario 4 and 5.